let's talk some properties of numbers. What do you say? So let's warm it up a little bit. Remember, if you're adding two negatives, you just add them as if they're positive and you keep it negative, right? So if I'm doing negative 18 plus negative 7, really I'm doing 18 plus 7, which is 25, and then we take the negative version of that, negative 25. Or, if it helps, think of negatives like money, and money you owe, positives, money you have. But when we have minus negative, like on number 2 here, remember we can change minus negative. Let's kind of cancel each other out. It becomes plus positive. 32 plus 3, 35. Negative 13 plus 6. Now you can think of money. You owe someone $13. You have $6. Do you have enough? No. So we know it's going to go negative. The rule for adding one of each kind is subtract your large number minus your small number, and then keep the sign of the bigger number. So if we did 13 minus 6, it would give us 7. You keep the sign of the larger number, which is 13, so it would be negative 7. And 2 minus 48. I have $2. I owe someone $48. I am short. 48 minus 2 is 46, so this would be negative 46. So we're going to talk a couple of properties, and these are nice actually. The commutative properties of addition and multiplication. So the commutative property says changing the order of the values you are adding or multiplying does not change the sum or product. So if you had 6 plus 4, that's the same as 4 plus 6. It doesn't make a difference. Same with 9 times 5 is the same as 5 times 9. Now you might think, well, duh, who cares? But when we get into some mental math stuff later, knowing that is actually pretty nice. It can help you out. Associative property says changing the grouping of the values you're adding or multiplying does not change the sum or the product. So check this out. 2 plus 7's in parentheses plus 3 is the same as if you put the parentheses around the 7 and 3. So that will make it nice when we're adding stuff. So like, we'll get there. Quit getting ahead of yourself, Mr. Plain. Come on. All right. Carlos rented a set of golf clubs. He's gone. There we go. Carlos rented a set of golf clubs for $7 and a golf cart for $12. He paid a greens fee of $23. Find his total cost. So he had to pay the 7, he had to pay the 12, he had to pay the 23. Now these aren't terribly complicated numbers. You could stack them vertically and add them, and that works. But we're trying to work on your mental math game here, huh? So what the associative property or commutative property state is, it doesn't really matter the order that you add this. It's all going to get you the same. So like, I would say do numbers that you know what they add up to. 7 plus 23, that completes a 10, right? That's 30. So 7 plus 23 would be 30. And then 30 plus 12 is pretty darn easy after that. 30 plus 12 would give you that 42. That's the same answer as if you did 7 plus 12 is 19 plus 23. It still gets you 42, okay? It still gets you there. And we're talking dollars. Since we're answering a word problem, we'll answer the way they're asking. You spent $6 for dinner, $8 for a movie, and $4 for popcorn. Oh my goodness, find your total cost. We got the 6, we got the 8, we got the 4. Again, you can just go left to right and be fine. But we're trying to work on our mental math. So let's do numbers we know add up to a 10 of sorts. 6 plus 4 is 10. And 10 plus 8 will give us that 18. Now, which property is that? We just added in a different order. That's the commutative property of addition and multiplication. Now, is it super important to remember the name commutative property? Not really, right? It's, can you actually do that? So can you group it correctly in your head and come up with the correct answer faster in your brain than you could have if you just go left to right? Identity property of addition and multiplication. Now these ones just make sense. The sum of any number, and remember sum is addition, the sum of any number and 0 is the original number, right? If you add 12 plus 0, it's just 12. 500 plus 0 is 500. If you multiply by 1, the product of any number and 1 is the original number, right? 60 times 1 is 60. Negative 50 million times 1 is negative 50 million. Okay? All right. So use mental math. Now we're going to use those grouping symbols. Now remember when it said the associative property, like it doesn't matter who the parentheses are associating with. Do you get it? Okay. So even though there's parentheses around the 81 and the 6, it would be the same as if the parentheses were around the 6 and the 9. It would be the same as if you had 81 grouped with 9. It doesn't really matter. If it's all addition, the parentheses are honestly pointless. So like here, if I was doing this one, I can do 81 plus 9 in my head pretty quickly. 81 plus 9 will get us to 90. And then 90 plus 6 is pretty easy to do. 90 plus 6 will give you 96. So we're trying to do as much as we can in our brains and really work on advancing our mental math skills. So here on A, if Mr. Plant was doing it, I would combine the 6 and the 14, because I know that would give me 20. And then 20 plus 7 gives us 27. Again, if you just went left to right, you'd end up there anyway. But this will allow you to use easier numbers. And here, when you add 0, nothing changes. So, like me, I'm just ignoring that plus 0. So I can do the 8 plus 2, and that would give me 10. 10 plus negative 7, I have $10. I owe my grandma $7. I pay her, I have enough. I get to keep 3 bones. Here, let's see what we can associate together. Ooh, 12 and 18. I know that 2 and 8 give me 10. So 12 plus 18 would give us 30. I also have this 5 and 5, which would give me another 10. So 30 plus 10 gives us 40. If you went left to right, 5 plus 12 is 17. 17 plus 18 is 35. 35 plus 5 is 40. This is just another tool to add to the old tool belt. All right, Mr. Plant, move over there. This guy, right? All right, so I see a 19, 21. I know that would add up to the 40. 40 plus negative 30. I have $40. I owe my grandpa $30. I pay him. I still get to keep $10. That was so much fun. Let's talk school supplies. Suppose you buy the school supplies shown at the left. Use mental math to find the cost of the supplies. Again, you could stack them, you can add down like you did way back in the day and be fine. But let's see if we can find a pair that works. 85 cents, 35 cents, yeah, sure. 35, 165, yeah. If you add 35 cents to $1.65, that comes out to exactly $2. And then it becomes $2 plus 85 cents, which would be $2.85. If you can't do that, stack them up and straight down and you got it, all right? But come on, try to stretch the brain a little bit. Stretch it out. Oh boy, oh dear. Okay, I can't scroll down. There we go. Use the supermarket receipt and mental math to find the cost of groceries. All right, we got a gallon of milk, $2.30. We got bread for $1.80. Apples, $2.20. All right, I know 80 and 20 gives me 100, which is $1. So if I do $1.80 plus the $2.20, look, the $1 plus $2 will give me $3. 80 cents plus another 20 cents would give me another dollar. So this part comes out to $4. But we still need to add that nil, $2.30. $4 plus 2.30 gives us that 6.30.
Yes! Yes!
Damn, yes. Use mental math to simplify 4 times 9 times 5. Now it says in order of operations, you always do the parentheses first, but the associative property of multiplication says that it doesn't matter the order that you multiply if it's all multiplication. So to me, I know what 4 times 5 is, not the brag. But 4 times 5 is 20. And if you're doing 20 times 9, just think of 2 times 9. 2 times 9 is 18. So if you're doing 20 times 9, you'd have 18 plus that extra 0, so $180. Because you don't know when you throw markers across the room. I'm so excited. When you multiply by 10, you throw a 0 on the end. When you multiply by 20, just multiply by 2 and then throw a 0 on the end. Let's try out some more of those. Remember, it does not matter the order you're multiplying as long as it's all multiplication. So to me, if I'm doing 25 times 3 times 4, I'm going to do 25 times 4 first, which is 100. Right? Think of quarters. If you have 4 quarters, that's 100 cents. And then 100 times 3 gives us that 3 bills, 300. 3 times 1 times -5 times 8. Great. 3 times 1 is just 3. You can ignore the times 1. If I was doing -5 times 8, I know 5 times 8 is 40. This would give us -40. And if we're doing a positive times negative, it comes out negative. Think of 3 times 4. We'll put a 0 behind it. 3 times 4 is 12. So 3 times 40 would be 120. All right, 2 times 8 times -15. Let's do 2 and -15 first. Positive times negative is negative. 2 15s would be 30. So we have -30 times -8. Now if you have a negative times a negative, remember that becomes a positive. So think of 3 times 8, and then we'll add the 0. 3 times 8 is 24. So 30 times 8 would be 240. More of this. I guess I'll draw all over the video screen here. All right, scooch over, Mr. Blank. Come on, dude. Oh wow, this is wild. If you have a negative times a negative here, results in positive. -2 times -1 is +2. So I'm just gonna rewrite that so we can clean some stuff up. Now, me personally, you're asking me? I would do the 5 times 2. 5 times 2 is 10. We can also do the 9 times 6. Remember your trick with the 9s? 1, 2, 3, 4, 5, 6. Put down your 6th finger, it's 54. So 10 times 54. And when you multiply by 10, you just throw a 0 on the end. So 10 times 54 would be 540. We didn't even need a calculator for that. That's how good you are. You've got this. Come on.